So I've been asked to give kind of a quick update on an initiative that a number of vendors have been working on in the big data space. My name is Mike Maxey. I work for Pivotal. We're a software company based here in the Bay Area. We focus on cloud and big data, and I've been one of the members of many companies that have been working on something we call ODPI, something we announced back in February as the Open Data Platform. So I'm going to do about 10 minutes, just a quick overview on what ODPI is, and then I'm going to hand it off to Steve, who's going to do a quick demo of Hadoop running on, I believe, Linaro's clusters. So ODPI, for those of you that aren't familiar with it, is really an effort to help drive some industrialization and enterprise features and standardization into Hadoop. So super complementary to Apache in that we are a downstream consumer of Apache projects. But what we've done is we've worked with a number of folks in the industry, which I'll talk about here in a minute, to build what we're calling an Odp Core. So similar to the early days in Linux, when many of the industry came together and built the Linux core, we're starting a similar initiative around Hadoop. And our goal is to really get a diverse representation into what this core should look like. What we've seen is, a lot of the Hadoop landscape's been dominated by 2 or 3, 4 major vendors who are building and configuring distributions to their business agenda versus sort of simplicity for the industry. So the lofty goal here is to help create a standard and really accelerate adoption of big data on any platform and any hardware platform as well. To that, we've announced in February with about 14 members. Since then, we're pushing, I think, about 30 members at this point. So representation across a number of different companies, from end users down to small startups in the big data space. And what we've seen is a pretty good representation of the entire stack. So this is really much bigger than, say, a Hadoop vendor or just Hadoop. If you start to look at sort of the participants of the group and you sort of categorize them everywhere from end users down to infrastructure providers, we have a bit of a chaos matrix on this slide, but it really does show interoperability across the stack. And what that means is we're getting input and we're getting investment from companies that are more than just Hadoop. They're actually driving enterprise requirements all the way from end users like General Electric and Telstra to solution providers like Splunk, big analytics companies like SAS, IBM, Hortonworks, Pivotal, and of course Linaro has joined as well as one of the sponsors here. So we feel we have a really good perspective that addresses the entire big data stack. And we're getting investment from not only dollar perspective, but also people perspective. And I'll talk a little bit about what the technical teams have been doing over the last few months. Our goal, again, is to really simplify consumption of big data, starting with Hadoop for the enterprise. And the way that we want to do that is we want to do it in the open, in a very open source way, with a community of volunteers that will represent the broad community that I just represented on the slide before. Our delivery will be something we call the ODPI Core, and this is going to show up in a number of different ways, and I'll talk about that in just a moment. But this is really kind of what our team is focused on. We're going to deliver a specification and a reference config and then tests so that anyone in the industry can use that reference configuration as part of their in-house use, as part of a product. Or if you're an ISV or an end user, you can test your application against that core and know that it's interoperable with anyone else who's using that core. So the idea is really a test once, run anywhere mantra for folks using this specification or reference configuration. The teams themselves have been working really hard. We started ODP with a really small core. Most of you that are familiar with a Hadoop distribution recognize there's anywhere from 15 to up to 25 projects in a standard distribution. We started with 4, and we started with 4 for really 2 fundamental reasons. One was in February, it was a small group. It was, it started with really 3 companies and expanded to a little over 10 quickly. But we felt that, having 3 companies or even 10 companies stand up and say, this is what big data looks like, was not really the right approach. Everybody can agree on kind of the core, which we started with, which is HDFS, Yarn, MapReduce, and Ambari. So we started small for a couple reasons. One, to accelerate it quickly. We didn't want to bite off more than we could chew. And secondarily, we really want the industry to help define how this evolves and grows over time. So what we would expect to happen in future releases is we'll start to see things like Hive, potentially Spark, pick your favorite Apache project, show up as part of the core, show up as part of our reference implementation, our spec, and again, create that standardization through a single test once, use everywhere methodology. We haven't announced ODPI yet officially. We've been talking about it a little bit publicly. Our official announcement is Monday, so you guys are actually getting a bit of a preview. On Monday, we do intend to open up our GitHub repositories. In there, you'll find the reference configuration, so a build of our spec, a written piece of our spec. There's an Ambari deployer. There is a sandbox, which is a virtual machine instance with the core running in it, so folks can download. And then in the future, we intend to bring a certification program so that users can certify their application, use the badge, and then publicly folks will know that it's interoperable with all the other ODP Core solutions. So starting small with the idea to really accelerate quickly as we move forward. How that evolves is something that's a little bit unique, so I thought I might bring this to your folks' attention. You know, the core itself, the content of that core, we're really looking to the industry to help define. So rather than saying, you know, the platinum members of the foundation who spend the most money get to decide, instead what we've implemented is this really one member, one vote policy where, similar to maybe blueprinting in the OpenStack space, where at the beginning of a release cycle, the community comes together and they really sort of prioritize a backlog of what's important. So if they think Hive is the most important project to add, they would prioritize that, or Spark, or, you know, choose your favorite Apache project. And the result of that is a prioritized backlog based on the community, to which a group we call the release team turns into a reality. So it's a very simple process where we have lots of input, lots of prioritization across the industry, and then focused release roughly on, say, a 6-month time frame, depending on how the development community comes together. So we've tried to create it very open for sort of the product creation side of it. Also on the development community, it's very similar to ASF. We follow ASF rules, so anybody can show up and participate. As they participate in the community, they can become maintainers. So maintainers choose other maintainers, just like committers choose other committers in Apache. And then we have an elected leadership in the development community called the TSC. So very similar open source processes where everything's done in the open via GitHub and public mailing lists, and really a merit-based society where folks are promoted to maintainers through their efforts. So that's a quick overview of what ODPI is. Again, it's relatively young in terms of open source society. We launched it back in February. We've grown pretty quickly to this point. You'll hear a lot more about it next week at Strata or ApacheCon if any of you folks are attending those shows. And we invite you to, you know, come visit our website, learn a bit more. We'd love to have you participate in the development community or in the membership community, or just consume our deliverables, our spec, and our reference configuration, use them and help us build it better. So that's a quick overview on ODPI. I'm happy to take questions maybe after. Steve, if you want to come up and plug in, and maybe I'll take a question while you're plugging in if there is any.
Hi guys. Whilst I plumb this in, I'll introduce us. This is Nachiket Boye. I'm Steve Cappo. We're in the Linaro Enterprise Group, and we're examining Hadoop on oops, sorry about this, on AH64. Okay, brilliant. Okay, so I'm going to talk a little bit in this session about the work we've been doing so far with big data on AH64. Nachiket, who you've heard on Monday but didn't see, was running the H2O demo, and he's going to do a little bit more of the H2O demo today. So I'll send him to the back again to run the demo once we've got to the demo stage. And we'll take questions together. So Open Data Platform is in its early days at the moment. As it's it's just happening now. We needed to start playing with something whilst we're analyzing things with AH64. We chose to start with Hortonworks, who are actually, I believe, a member of the Open Data Platform as well, and we will be moving towards Open Data Platform to try and be as agnostic as possible with our work and try and make sure it feeds back to as many people as possible. So moving on to AH64, the bulk of our actual time has just been spent ramping up on build systems more than anything, and tweaking build logic. This is kind of good news because we've not found any really significant AH64 related problems. At the moment, it's been reasonably mundane things. So for instance, occasionally somebody might put x86 assembler inline in the middle of a function somewhere. That's a reasonably trivial thing to find and fix. The most complicated thing we've come across so far has been pertaining to Node.js. So by default, quite a lot of build systems for these components for Hadoop will quite happily download the x86 version of Node.js and try to run it on the ARM build system. It doesn't work well when that happens. More seriously, though, Node.js for AH64 is fully released now, but it's quite recent. So some early JavaScript code that is used in web apps that are contained in these Hadoop components, for instance, Ambari is one that has a web UI. The web UI itself is compiled using Node.js. There are a couple of cases where there are dependencies that rely on an older version of JS. But again, that's reasonably easy to fix, find and fix once you go through the Node Package Manager dependencies and everything. Mostly, things are just working. So we are investigating Open Data Platform distro as and when it's out as well. But we're also got to focus on upstream as well because we want to try and keep an eye on the state of play with the code to spot whenever any changes come in which are not beneficial, shall we say, for AH64. A significant part of the big data work for ARM is going to be centered around the OpenJDK. Hadoop, Spark, and many other components are hosted entirely on the JVM. So a bulk of our profiling and optimization work will be geared towards providing useful feedback to Ed Neville and his colleagues so he can usefully improve OpenJDK as and when we find anything. We've already found a very quirky bug which managed to fall through the cracks whilst running Spark build systems, and that's already been fixed. So we're already helping OpenJDK get a little bit better. In terms of what we actually need to do, most of the components that were deemed pertinent have been built successfully for AH64. We need to package them together into the standard distro packages that software such as Ambari will use to deploy them en masse. We don't have much Debian RPM build logic at the moment, so that has to be sought out, found, and fixed. One of the biggest concerns I have for the big data work in general is nothing to do with AH64. It's entirely centered around the build systems that we use for big data. So for instance, Maven is one build system which downloads prerequisite modules for applications. These are known as Maven artifacts. There are quite a lot of Maven artifacts that are downloaded when one builds something with Maven. It can be slow. Whilst visiting in-laws in China, it was very slow using Maven on my laptop. That is something we should probably all think about. It also, more seriously, the sort of transient nature of the Maven artifacts makes it very hard. Well, for one, it's a security concern. For two, it's very hard to produce reproducible builds. So one area of interest that I have in particular is the distros do appear to be packaging certain Maven artifacts in a quite nice way, and that is something I think we should certainly investigate, because being able to reproduce the build reliably in a trusted manner is an extremely important thing to do. We need to deploy clusters and profile them. The testing and profiling will be geared again towards the JVM. So can we get useful information for the JVM people if there's anything in the JVM that is changing? Are there any high-level Java changes or scalar changes we need to make. So we're not really thinking too much about AH64 at this point. The other big task we have to do is we need to devise actual workloads that have some semblance of reality about them. I don't particularly want to be running word count. I don't particularly want to be running TeraGen, TeraSort. We want some other workloads to stress all these components because all these big data components fit together in various different ways, and we need to test how all that works together. So that's all the work we have to do. I was going to hand over to Nashiket, who's run over to the back now, and he'll give a quick demo of a H2O machine learning software running on top of Hadoop.
Thank you, Steve. So we can see the H2O stack over here. So basically, H2O is a machine learning software written in Java. Main idea here is that data collection is easy, but decision making is hard. And that's how H2O will help us. We'll see that. So it easily integrates with HDFS, and it has various highly advanced algorithms for deep learning, and it supports Python, JSON, Java, and it also has a REST API. So over here we can see that H2O is running as an application in Hadoop. We have 6 AMD Seattle nodes, and total memory of 332 GB allocated to H2O for now. So each H2O process runs as a mapper process on each of the node. So this is the H2O flow, which is a open source user interface. In simplest terms, it's a sequence of executable cells, and an example of cell is this particular input over here. So each cell has input field to enter commands, define functions, call other functions, and access other cells. So we are now going to import a data set into H2O flow. In this demo, we are going to create a model for predicting delays in airlines. So I'll go ahead and import a data set. You can see it's quite easy to use. It auto-completes my path to HDFS. So right now it shows all the files which are currently available in my current directory, and I'll go ahead and select this particular file, which is the airlines in a database from 1987 to 2013. So the first phase is parsing of the data set. Currently, we have the data set in CSV format, but for the model building process, we need it to be in a hex format. So we are going to convert this. We can see this is the CSV format. The columns are given here, and all the values are on the right side. We are now going to parse it to hex format for the model building process. So while that is going on, I'll show you the water meter, which we saw on the keynote on Monday. So it shows status of each node on the cluster and each core for each node in that particular cluster. So while that is running, I will also give a quick demo of another feature called cluster status, sorry, So again, like each function runs in a cell, it's called from a cell. So getCloud is a function name for cluster status. And we can see over here that all nodes are listed. It gives real-time status of the load level, the CPU usage, garbage collection usage, and the disk usage, which is the temporary directory in Hadoop, which is used for storing temporary results. And apart from this, we can rearrange the cells in a flow. So for example, I can just move this up. So now it's above the current job which is running, and we can push it down again. And we can also save it to a file which gets stored in the HDFS. So demo, and I'll just save it. So it stays saved, and you can easily access the file over here, which was created a few seconds back. And so you can create a sequence of cells, save it, and then you can either debug a flow by running each cell, examining the output, or you can just run one cell at a time, or you can run the entire flow all together. So okay, it's almost done, and once that gets built, we'll go on to model building process. So yeah, I mean, the flow combines graphs, text, mathematics, and code execution in just one single place. So it's quite easy to use, and I just like it. So let's go ahead and view the hex format data. So we can stop that. I'll show the water meter again. We can see that all the nodes are idle now. So yeah, this is basically the output of after the parsing. We can see the column names over here. It gives the minimum, maximum, and mean value for each column. Yeah, and now we can start with the model building process. So we'll select the generalized linear model. So we'll select the columns which we need to create a model for predicting airlines delay. So we select year, month, day of month, day of week, scheduled departure time, the unique carrier number, origin, destination, and is departure delayed. So that's going to be our response column, is departure delayed, and the answer is yes or no. So the family will be binomial, and we'll leave everything as default and go ahead and build the model. So yeah, the model building process has started, and we can see that all the cores are used to the maximum capacity. If you observed in the file parsing phase, the usage of CPU was not at maximum, and that is because I'll get to that later in the graphs. So, yep. So it should be done in a few seconds. So yeah, basically it easily helps, H2 easily helps to apply math and predictive analytics to solve business problems. So yeah, it's almost done. We can see the CPU are going back to the idle stage. So yeah, this is the generated data from the model. All the machine learning experts can use this to make predictions from the data. We have the area under the curve over here, and other statistical data available. So yeah, how does it scale? And yeah, the scaling is linear. Yeah, going from 1 node to 6 nodes, we got a linear scaling. For both 32 and 64 gigabytes per node, we get the same graph, but it is because we have the file is less than 32 GB, so it fits easily in the easily in memory, and we don't need extra memory. So, and this is the file parsing phase where I was talking about that the CPU was not heavily used in this phase, but that is because the network right now I'm using is 1 gig interface, and after 2 nodes, the performance suffers from a bottleneck. It flatlines and gets worse as you increase the nodes. But yeah, with 10 gigabits, Ethernet, you get, again, a linear scaling. So to summarize this, yeah, ARM64 processor, the AMD Seattle scales linearly, and also Linaro OpenGDK scales linearly with respect to number of nodes on H2O. The only bottleneck is memory, so you need as much memory for the amount of the file size which you require, and the other bottleneck is the network. 1 gig E suffers heavily from bottleneck, and 10 gig E scales linearly. So yeah, back to you, Steve.
So, sorry about that. Before we wrap things up, guys, I was going to say thank you for your attention, and if you've got any questions for Mike, myself, or Nashikat, now's the time. Are there any microphones at all to hand around?
The right way your feet.
Ah, thank you.
I'll do the one. I'll walk around it. Questions?
What will you be working on next once you move to the ODP platform?
Yeah, so I believe the question is what we'll be working on next after ODP. So, because the microphone's off. Oh, okay. Essentially, we are going to have one thread of CI work where we try and get the CI to be a little bit more elaborate, is one area we're thinking of. At this current moment in time, we're trying to explore the problem domain more than anything to see where there are any bottlenecks or what requires our attention, because this is a new space for most of us working on it within Linaro, at least.
What is your expectation of the current Hadoop vendors adopting ODP? How many of them would adopt it? How broadly? How deeply? How passionately?
So it's a little hard to hear. What is the expectation of the current?
Vendors adopting ODP and releasing products.
Oh, okay. So the question was, what is the expectation of the Hadoop vendors adopting ODP and releasing products? So I think that the folks who are part of ODP, so the vendors that make distributions include Pivotal, Hortonworks, IBM, Altascale, and Infosys. There's also a couple end users that roll their own. They've all embraced this spec. It's very early. So the intent is, within the 6 months to have something that is not alpha, but a release, a generally available release, for lack of a better term, and that all of the ODP vendors will either build their own using that specification or just take the reference implementation and ship it as product. So the idea is beyond the vendors themselves, they can then test against that release for interoperability. So folks like SAS, who's a big analytics company you may or may not know, they're very interested in not having to test all 5 of those distributions independently, and the idea that if they can just test against ODP and be done is very compelling to them.
Any other questions? Yes, please.
So is ODP architecture independent, or will you have a reference for x86 and a reference for ARM? Or
It is independent, which is why we have a specification versus everybody has to use the same bits. When we initially actually set out with ODP, we thought of, hey, everybody rallies around the same set of bits and it all works well. But as you start to think about different implementations, it becomes very difficult. So we do expect different groups will pick it up and use it in different ways. IBM has many platforms. I'm sure they'll try and use it in many ways. And having Linaro involved is a great, for this community to start getting involved. We're excited about that.
Is ODPI going to have an ARM CI loop?
Sorry, I didn't hear. I couldn't catch that one either.
Will there be an ARM CI loop?
Will there be a CI loop?
Yes.
Yeah, so our intent is to build out infrastructure for building that reference configuration, and anyone can use that as well as a configuration in CI group. It's small now. I mean, it's been about 25 people working for 3 or 4 months, so it will expand significantly, but absolutely we'll have everything open and available, CI test frames and test suites, et cetera.
Right, and Linaro is planning to leverage that, so we will be participating and leveraging in it. Any other questions? Cool. Well, let's give a hand for our first Ecosystem Day talk.
Thank you.
Yeah.
Oh, I need that. Sorry. No problem. That's fine. Is it dead? Oh, great. Steve, did you turn off my internet? Kind of. Not getting anywhere. Oh, really? Okay. Oh, there we go. Finally. Thank you. All right, so thanks for bearing with me. I'm just going to roll from here. The next talk we have is from Mirantis. We have Kyle MacDonald is going to come up here and talk about OpenStack. Kyle is one of the original members of creating OpenStack. He's an advisor now to Mirantis and also to Big Switch. So, Kyle.
Good morning. So, I sat in on some of the other chats. We got super technical, and I was trying to think of, over the last 2 days, what kind of content I could bring you that would tell you something about OpenStack that you didn't already know. And I decided that that could be a super hit or miss. So instead, I'm going to give you just a few minutes about kind of things you should know about OpenStack, and then, and this may be completely a mess, but I wanted to open it up and basically let you ask me questions, and I'm here to tell you anything I can about OpenStack and sort of the ecosystem that we see. A little background on me, I'm a strategic advisor at Mirantis, Big Switch Networks, and a number of other companies. I've been doing OpenStack since it was created. OpenStack is now, I think, we're probably in a really good competition with Docker on fastest growing open source projects. But we're now much further along than we were probably about 5 years ago. We've started with what was originally just cloud. And now we're expanding that to cloud, the workflows, the applications, and sort of delivery of catalogs. It's becoming all of the things you need to sort of automate the infrastructure of your IT and then start to build the rest of the tooling you need to make that work. So those are all the flowery words. But a second part of this is, and yeah, I'm just going to leave this up here because it's the branding you're supposed to do, but I think there's a second thing that, from the OpenStack community, sort of the way we think about ARM is evolving right now in two aspects. The first is that we really, as people who build OpenStack distributions and go and deploy OpenStack, think of OpenStack as an application, right? We think of it as something that an operating system and all of the tooling underneath should give us that same experience on ARM as we have on Intel. And sort of with a few fundamental quirks, that's a thing that's going to change. But we really just think of it as OpenStack. And this comes down to one of the fundamentals of OpenStack, which is this idea that we are providing you an abstraction to your infrastructure, right? And so for our standpoint, that abstraction is really something we are looking for the ecosystem to help us with. And so that's really our interest in ARM. That's kind of what we're doing. In terms of ARM clouds that we're seeing today, so we're seeing some interest in the financial services sector. Obviously, a lot of the quants workloads and that sort of thing lend themselves very well to ARM workloads today. And we're also now seeing a lot of the telco and service provider, think carrier, think SDN, think NFV, starting to look at how OpenStack on ARM allows them to sort of contain NFV services in a way that prevents noisy neighbor problems. This isn't a new sort of approach. It was done a couple of years ago by Verizon. But now we're also thinking about how can that be more network friendly? What are the networking elements that sort of go there? How's that work? So that's a little bit about the projects, but here's the part where I turn it over to you. This is the Ask Me Anything of OpenStack. What can I tell you about what we're doing and who we're working with? And do we have somebody with microphones? All right, there has to be a question here on OpenStack. I'm going to bring you this.
So I was kind of curious what's going on with LXC and LXD within OpenStack right now.
So LXC is a first-class hypervisor in the context of OpenStack. There's a Nova plugin that was created many years ago, 3 years ago, for LXC. And we actually now, following on to that from a higher level, OpenStack has a project called Magnum that's been spun up. And inside of Magnum, you're able to do plugins. And so Magnum is going to handle all of the Docker container and sort of giving you a container service. So that's all being spun up out of the OpenStack Magnum project, which I think moves into being real later this year. Are you using LXC in OpenStack? Have you done any work with it?
No, I'm pretty much a rookie with OpenStack. We have a kind of primitive deployment in a lab at Linaro, and I don't know how the mechanics. I mean, normally with how I've used OpenStack, you kind of upload an image, right? And LXC doesn't really work that way, so I didn't know how the mechanics of something like that might work in OpenStack.
Yeah, so Project Magnum is actually the place you want to pay attention to there. And what we're doing is, it turns out the semantics for doing virtual machine spin-up and sort of container spin-up are based on image as well as a couple of other things, right? So permission settings and sort of things like that. There's a bunch of, the primitives that you would use to actually talk to it are very different. And so as a result of that, we're actually expanding in Magnum the interface that you use and sort of the API you use to spin up images in a container, and we're separating that out from sort of the approach that was done in Nova before, which was sort of making it look like you were spinning up a hypervisor, and then behind the scenes there was a bunch of code to do the extra cleanup work. So there you go. Along with that, there's going to be probably work that needs to be done around storage persistence and how we bring storage persistence into that model. And sort of how we tap. So there's a secondary project in OpenStack called Cinder, and we're going to want to walk through and look at how Cinder can be used there. There we go. Any other questions?
So what are the main pain points you have in order to get the same experience on ARM like on x86? So what sucks? Or what sucked?
So I think right now, the question was what pain points do we have sort of in making that experience work? And actually, so I went to go do the poll of engineering, and it came back that we don't actually have a lot of pain points. Our major pain point right now, which is why when I went to go make slides, this was kind of a hard thing to do. It's actually a pretty solved problem. The biggest problems we have are really going to come around sort of the SDN and networking interfaces, right? And specifically, how do we, we're going to, so if you think about the problem of cloud and you think about the idea of a large number of virtual nodes on a system, right? A lot of the stuff that we've taken for granted sort of in the VM world is very, and basically thank you VMware, has been very well matured, right? We understand how to see different traffic patterns between VMs. We understand how to sort of bring those up into the application. Those sorts of things are done. When you start doing that with networking, and you think about things like DPDK that we have in sort of the Intel world, and a lot of the tooling that's been there to sort of grow that and make that mature, that enables sort of large throughput and very dense machines to sort of happen for us. I think getting a lot of the ODP stuff into mainstream SDN and having those be supported configurations and things like the Open Contrail project, working with guys like Metaswitch and their Calico project, and then working with guys like Big Switch Networks and Cisco and Nicira to sort of make it so that those are all first-class citizens for the ODP world, and that sort of just works in a way that everybody understands. I think that's probably the last thing that needs to sort of be solved.
So one of the goals of Linaro is to make sure that ARM is a first-class architecture for OpenStack. And so there's been a lot of activity around setting up test rings and trying to get through all the OpenStack components. But one of the problems is that every other day there's a new OpenStack project starting up, and we can't even get through the existing ones. So what advice would you have for Linaro to start making some progress where at least we have core OpenStack projects that can be well supported on ARM?
Okay, so this is so OpenStack is a foundation. We took this philosophy of a big tent philosophy, which is to bring both OpenStack projects that are directly related to sort of running a cloud and cloud infrastructure, but then also the things that are sort of halo effects, right? Stuff that you need to use in the cloud or things that benefit from that. So yes, that has the effect of we have lots of people now participating and doing lots of cool things. The downside is, in this case, you could consider it upside if you want to think of the innovation that we're doing, but absolutely, we have a lot of projects and they're at various levels of maturity. One of the ways to sort of look at this is there's a set of what we consider foundation and core projects, part of OpenStack. And then there's what we consider incubated projects. So all new projects in OpenStack, once they officially get named a project, go through an incubation cycle. It's about 3 to 4 OpenStack releases, and then they get voted in and they're ready for prime time. So what I would suggest is you could spend all of your time, from an official sort of this is a supported platform standpoint, looking at the official projects of OpenStack. And then I think what you do is you look for the projects that are being nominated to be incubated, because once they're incubated, they have foundation support. We bring them into the integrated roadmap, et cetera, et cetera. So I think you want to look at those projects and then use the period of time while they're incubating to sort of seed yourself and become part of that community and sort of engage there. And if you want, I'd be happy to help connect you to some of those folks later. But that's, if you look at the way the big companies are sort of handling OpenStack distributions and thinking about how they sort of package and sell OpenStack, for those people who aren't just going bleeding off trunk, those distributions for the most part are really just shipping what are, actual OpenStack projects, right? Rather than incubated or kind of developing projects. So that's one way to look at this. The second way is there's a set of standards and sort of like formally recognized ways of doing things. It's a thing called DEF Core. And that's inside of OpenStack. You can Google it, DEF Core OpenStack. Rob will have plastered the internet with it, I'm sure. And so when you look at that, that's basically all of the services you need to run OpenStack and sort of gives you a fitness test to say, these are the minimum viable things you need to have it actually, A, be called an OpenStack from a legal and trademark and organization purpose, but it also shows you all of the things that are sort of required. And so those are the that's the absolute litmus test for, could this be called an OpenStack? And these components are what make up the skeleton of OpenStack. And so I would say kind of between those two things, you could make sure that all of the stuff in DEF Core rocks, and then partnered alongside of it, all of the current projects are sort of getting the right kind of attention and going through the testing process. And then the place to focus the community effort is on A, maintenance with those existing projects, but B, incubating and growing in those new people, new communities.
Any other questions? There you go.
Can you talk a little bit about the status of bare metal provisioning and in particular its status on ARM?
No, actually I can't. So Ironic we released about 2 years ago. And Ironic was actually, so the bare metal provisioning inside of OpenStack is a project called Ironic. Ironic is now actually a full-time project in OpenStack. It's fully committed. And I know that there was work done to do that with ARM, but I don't know the status of it at the last count.
No.
In fact, most of the customers that we've talked to, I haven't actually seen that much bare metal sort of in the world. There's some unique places where it's been seen for like, the big data guys love it, and there's a couple of the NFE sort of workloads that lend themselves well to it, but other than that, we don't run across very much Ironic sort of in the world. And the other provisioning schemes that sort of people have, IPMI, the Metal as a Service from Canonical, those sorts of things, kind of do most of that job.
So I should actually state that we are planning to concentrate and work on Ironic for ARM. So that is on the roadmap for the OpenStack lead project.
How many of you are using OpenStack right now? This is a, okay, that's a good number of hands. And how many of you have done any development work with it or looked at the code? Okay, you two get beers later. Oh, and 3 of you get beers later. Cool, any other questions I can answer for you? All right, I will be here for the next couple of hours. It'd be great to hang out, come say hi.